Okay, so we spent a lot of time on measurement and geometry, and we're kind of wrapping up the chapter with obviously the test this week. So we have our one last lesson, and it is on something called surface area. Okay, so we're going to see prisms today, and we're going to talk about the surface area of these prisms. All right, and this could get a little confusing. So I want to make sure I kind of dive a little deeper than usual on this. So here's the thing, is the idea, if I was to teach this by itself, more than likely you guys would be like, okay, that's pretty easy, that's not difficult. However, here's the problem, is that when we see prisms, 3D shapes, right, with parallel bases that are congruent, when we see prisms, we automatically think of something like this. We think of little cubes that fit inside, which means it's volume, right? Well, today we're dealing with prisms, but we're talking about a different part of those prisms. It's kind of like when we talk about area versus perimeter of like a rectangle. Okay, two different things. Same rectangle, but you can talk about two different parts of that rectangle. That's kind of what we're dealing with today. We're dealing with prisms, but we're going to talk about, not volume, we're going to talk about something else. Okay, so before we go on to this lesson, I'm actually going to want to talk about a shape like this. Okay, now if I was to give this to you, this shape, right, and I was going to say, guys, go ahead and find the area of that shape, the total area. Okay? Well, you guys would, of course, probably take that shape and treat it like a composite figure, right? It's just a bunch of squares all over the place. So if each square was like, I don't know, 2 inches by 2 inches, you'd say, oh, 2 times 2 is 4. That area is 4, and then each of them would be 4, right? If they were all congruent. And then what would you do at the very end? You add them up, right? So you'd find the area of every single square, and then you add them up, and then boom, there you'd have your total area, right? That's what we've been doing with composite figures, all right? And that's basically what that is. Now, what we're doing today is we're doing the area of composite figures, kind of, all right? Sort of, all right? And so what I mean by this is what I'm talking about. We have all of these boxes. Found the area of each one, we add them up, right? Well, here's the difference between our previous lesson and today's lesson. I'm going to take this shape and I'm going to build this composite figure, and you have to use your imagination a little bit, but I would build it into a three-dimensional figure, a cube. And surface area, ladies and gentlemen, is exactly like area of a composite figure. It's just that you could think of the figure being folded up into a three-dimensional shape. And so here's what we would do. We'd find the area of this, the area of that, area of that, and that. Just like we did before. And guess what we're going to do at the very end? We're going to add them up. And that's what surface area is. Okay? So we're not finding out how many of these little things fit inside here. That's not what we're doing today. We're actually finding exactly what it's called. We're finding the area of the surface area, okay, of a 3D shape, of a prism. Okay, in this case, yeah, it'd be a cube. So basically, it's a review of composite figures, just like though the thing is folded up into a 3D figure. Okay, steps are going to be pretty much the same. So let's get to our vocab. All right, surface area of prism. So here we go. Surface area, everyone. Surface area. Let's try that one more time. Surface area, everyone. Surface area. All right, so here's what your book says. It says it's the sum of the areas of all the surfaces, okay, or the faces, of a three-dimensional figure. Sum of the areas of all the surfaces, or faces, of a three-dimensional figure. So here's that's a pretty decent and easy definition. However, here I just put this. It's kind of like the area of all that you can touch, right? Because when you talk about volume, you rarely talk about you talk about the space inside, and unless it's like a house you could walk into, right? I mean, if it's just a little shape, you can't really touch the inside of it. Okay. So it's the outside part of it, all of the area that you can touch. Okay, so with that said, we already talked about that. Let's go ahead and you can put your binders away. Grab your book, page 668. Eyes up here as soon as you're ready to go. Okay, so one of the easiest ways to solve these kind of problems is to stay organized, and I know some of us probably struggle a little with that. All right, so I'm going to in this lesson, I'm going to teach you a way to keep your work organized. All right, and to be able to, of course, get the right answer in the process. So, but before we do that, here's what I want to talk about. If you take a look at 668, problem number 1, all right, I'll go ahead and draw it on here. Looks something like this. And it says this dimension 6 feet, this dimension here is 3 feet, and this dimension, is 4 feet. Okay. First of all, what kind of shape is that? It's a rectangular prism, and with one person telling me, there you go. Good catch. All right, it's a rectangular prism. All right. Now, there's a famous rectangular prism that we usually use when we play like board games sometimes. What kind of rectangular prism is that? Nobody knows? Probably not a lot of us play board games nowadays. All right, good old-fashioned board games. Okay. Maybe Monopoly. What do you guys roll whenever you find out how many spaces there are? Oh, there you go. Okay, so yeah, dice, right? You roll dice to find out how. Okay, let me ask you this: on dice, what are your options that you can roll? 1, 2, 3, 4, 5, 6. Why do you think there's only 6? Why isn't there 7? Okay.
There's only 6 sides.
There's only 6 sides, okay? So, the reason why I'm going over this is because anytime you get to a rectangular prism like this, okay, by the way, dice, right, is a famous rectangular prism called a cube, right, because all the sides are squares, okay, and that's, when you roll it, it's an even chance that, because all the sides are the same size, there's an even chance that it's good. Any of those are going to roll up and show up, right? So, but anyway, it's a cube, but it's 1 through 6. All right. Well, why is that? It's because all rectangular prisms have 6 sides. Now, I also want to say something else about a rectangular prism. We talked about this just briefly earlier on, but I want to show you guys something. Okay, let's grab the good old Kleenex box here. Okay, this isn't a cube. This is a rectangular prism. But here's what I want to talk to you guys about. Okay, how many sides does this have? 6. Okay, testing you guys at, let me see if you were listening, which sounds like some of you guys weren't. 1, 2, 3, 4, 5, and 6. Okay, 6 sides. Always 6 sides. Rectangular prism. Always 6 sides. Okay. Now here's what I'm going to try. I mean, if I was to ask you how many of you guys want to do half the homework, I should say make each problem twice as fast, I'm sure most of you guys would raise your hand. Okay, at least all of you that would be listening to me right now would be raising your hand. So let me ask you, I'm going to cut your time in half here. Okay, here we go. What do we notice about this side and its opposite side? They are equivalent. They are the exact same. They are congruent, meaning that they have the same area, they're the same size. What about that one there and its opposite side?
Congruent.
They're both congruent. They're the same. That side and that side. Okay, you guys get the idea? So listen, with a rectangular prism, with the knowledge I'm just sharing with you guys, if you've never noticed this, we don't need to find the area to 6 sides. We only need to find the area to 3 sides. Why? Because then we're gonna double it up, right? So that's what I'm talking about. I just cut your workload in half. You're only having to find the area of 3 sides when you're dealing with a rectangular prism. Guys, rectangular prism, remember we talked about in geometry, just a little review, is that opposite sides are congruent. That's why it's hard to tell which side are the bases of a rectangular prism, because realistically, according to the definition, we have 3 different sets of bases on a rectangular prism. Anyway, let's get to this. All right, here we go. Page 668, problem number 1. There it is. Here's what we're going to do. Step 1, and I'm going to go, I'll come right up over here. Okay, step 1. We know there are 6 sides, so here's what we're going to do when we do surface area. We are going to number 1, 2, 3, 4, 5, 6. One of the biggest mistakes students make is they forget a side or even 2 sides and they get the wrong answer. That right there took me an extra 3 seconds to number it, and it's going to assure me that I don't forget a side. Okay? Now here we go. Step 2. I'm going to find the area of the very first side. Now it doesn't matter where we start, right? Kind of like a composite figure, because in the end we're going to add them all up. So here's what we're going to do. The one that is like basically right up front, I'll start with that. Now the nice part about this problem is it's a rectangular prism, so of course all we do is we multiply the base times the height, or length times the width, right? So we have 6 times, and then this height right here is 4. So here's what I'm going to do. I'm going to label, and if I don't label, I may lose track of the side, the dimensions of the sides that I found the area to. And I might double up on a side, and that's not what you want to do too. So all I'm doing is I'm recording the side that it is. It's the 6 by 4 side. Of course, the area is 24. Okay? 24 square feet, but we don't have to put the units right now. Here's what we're going to do next. Step 3. Remember, it has a twin. It's congruent base on the other side. So I don't need to look at it. What we're dealing with, of course, is we're talking about that side on the back we can't see. It's also 24 square feet. So I'm just going to write down 24. I'm not going to deal with put 6 by 4. I'm not going to do anything else. I know it has a twin on the other side. I just write down the area of that twin. That's it. Okay? Step 4 is I'm going to repeat. I'm going to repeat this 2 more times. So I'll do this little side over here, this right side, and this is a 3 by 4 rectangle. So that's what I'm writing down. This is the 3 by 4 side. And that one's easy. It's 12. And of course, because I'm repeating, and I guess I should say repeats step 2 and step 3, is I'm going to go ahead, and if this side is 12, then this left side that we can't see is also 12. I'm going to write it down. And I'm going to repeat it for this top side here. So this rectangle up on the top is a 6 by, and this side right here is the length of that. It's by 3, a 6 by 3 side. And 6 by 3, of course, is 18. If the top is 18, then the bottom is also 18. Now comes step 5. And that is, it's a composite figure basically folded up in a 3D shape, right? So all I'm going to do is I'm going to add the sides. So you can either add, and I actually take a look there, and I could look at this. 12 and 18 is 30. 12 and 18 is 30. 24 and 24 is 48. So 48 plus 30 and 30 is 60. Okay, you can get it that way. Some of them you can do that. Some of them, of course, you're going to want to use a calculator. 24 plus 24 plus 12 plus 12 plus 18 plus 18 equals 108. And you guys know where I'm going with this. We'll call this step 6. Don't forget your units. Now here's where it gets, you have to be very careful because the last couple days we've been dealing with volume. First of all, the units are in feet. Square or cubic? Square, right? Because guys, we're not finding how many cubes can fit inside. We're finding basically how many squares can fit around the outside. It's the area of the surface. So it is squared feet, not cubic feet. Because it's a surface area, not volume. 108 square feet. Okay? Questions? Gotta try one. No questions? All right, here's the one I want you guys to try. By the way, let's take a look at 671. I'll start you. I usually don't do this, but I figured on this for today, we're going to actually convert the dimensions to decimals before you solve. Okay? So if you take a look at problem number 14 on page 671, you see where it says 4 3/4 inches. You could put 4.75 inches. Use that. And then, because I want you to focus more on the surface area skill rather than having to deal with adding and multiplying fractions, okay? So, and then 6 1/4 inches can be 6.25 inches, 6 25/100 inches. So you could write that down where it makes it a little easier for you. Steps are still the same. Any questions? All right.
What was the
4 75/100, 4.75. Any other questions, guys? All right, I'll give you guys a couple minutes. I'll check in with you guys then. All right, go. Okay, you can see some of you guys are still working. How many of you need more time? Okay, all right. check with you in just a bit. Those of you that finished, okay, you can start working on some of the similar problems for your homework. All right, how many of you still need more time? Okay, I'll give you guys about 30 more seconds, okay, and then we're gonna share. Okay. Go ahead and turn to your neighbor and share, starting now. Go. Okay, so I sat there, and maybe it's because it's a morning, but I completely messed up on drawing this three-dimensional shape. So it gives us a decent idea. The bottom line, though, is that I can use the dimensions here to still solve it, and it's a rectangular prism, so that's what really matters. So, all right, so 3 by 4 3/4 by 6 1/4. It's all in inches. So here we go. I'm going to go ahead and I'll do this problem right here. So step 1, following my steps here. Step 1 is I'm going to label. It's a rectangular prism, 6 different sides. So 1, 2, 3, 4, 5, 6. Okay, I'm going to go ahead and focus in. I'll focus in on this one right here. This is a 3 by 4.75. A 3 by 4.75. 4 3/4, 4 75/100. Okay, it's a rectangle, so it's just base times height, or length times width. So it's 3 times 4.75 equals 14 25/100. Now, if that side is that area, then I know that this side I can't see down there is the same area. It's a rectangular prism. Now I'm going to repeat those two steps 2 more times. So here we go. Let me go ahead and I'll focus in on this side here. This is a 6.25 by 4.75. So 6.25 by 4.75. So I'll punch that into my calculator, 6 2500ths. Bring it over here. Times 4 7500ths. Did I punch it in right? 6 2500ths times 4 7500ths equals, I get a pretty ugly answer here, 29.6875. If that is this side, then that back side is going to be the exact same thing. And the last side is this bottom side here. So this is a 6 2500ths side right here by this length here, which is just by 3. So 6 2500ths times 3 equals 18 7500ths. And again, if that bottom is that, then the top is also that. Okay, a little uglier than what we did before, but it's not much harder since we have a calculator. So I'm going to turn around and I'm going to add these up. So 18 7500ths plus 18.75 plus 29 and 6,875 10,000ths, so 0.6875 plus 29.6875 plus, and now 14.25 plus 14.25 equals 125 and 375 thousandths. And when it's ugly like that, we're going to want to make sure that we find out what it says. Round to the nearest tenth if necessary. Well, it is necessary. So, of course, I need to round. 7 makes the 4 go up, so we end up with 125 and 4/10. And can't forget our units. It was all in what? Inches, right? So, inches squared, or squared inches. Okay, questions about that one? Okay. All right, here we go. The next one I want to take a look at. Let's go back to 668. And let's take a look at problem number 2. All right, problem number 2. There it is. Rectangular prism? No, what is it? Yeah, so we're dealing with something new here. Triangular prism. Okay? So here is what I want to talk about. Okay? The steps are going to be the same, but this is a little more challenging, and here's why. Okay? First off, how many total sides do we have? Well, let's count. We have this triangle here, and it's called a triangular prism, right? Because it has a congruent triangle on the other side, which is this back side here. That's 2 different sides. However, we have this right side here. That's the 3rd side. We have this side over here. That's a 4th side. And by the way, that's a rectangle. We have this rectangle here. And then we have the bottom rectangle. A triangular prism doesn't have 6 sides. It has 5 sides. So 5 sides. Out of those 5, the 2 bases are triangles. But what are the other 3? The rectangles. The rectangles. Now here's the other thing. The triangles, congruent. But a majority of the time on our homework, the rectangles are not going to be congruent. So these are a little more challenging. Okay, not harder, but it's just going to take a little longer because we have more. Even though we only have 5 sides, we don't have a lot of twins. We only have 1 set of twins, and that's the triangles. Okay, so you're going to see that the steps are the same, but going about it's going to be slightly different. Okay, so here's what I'm going to do. is, I'm going to go ahead and flip this paper over here. And so we're on page 668, problem number 2. All right, so let me try my best to draw this thing. I'm going to draw it where we can see it a little bit better. So kind of slant it over a little bit. So here we go. All right. So what we have is this is 4 meters here. This is 6 meters here. This is 3 meters here. And it says that this line right here is 5 meters. So what you're going to see me do, I'll still go through the steps for us. All right. We'll still write down the steps, but we have to be careful when we do this. This is a triangular prism. So here we go. Step 1, right, was write down, but before it was 6, but this only has 5 sides. So it's 1, 2, 3, 4, 5. Now, what I'm going to do is I'm going to start with the triangle. All right? And let's just do this triangle right here. Now be very careful. A triangle is 1/2 base times height. The base is here. It's 4. So it's 1/2 times 4. But the height, ladies and gentlemen, be careful. It is not 5. The height is right here. That's the same as this. It's 3. So a lot of us can do this part in our heads at this point, right? 4 times 3 is 12. Half of 12 is 6. Now, step 3 is because it's a triangle. I'm going to put a little star right here. Because it's a triangle, I'm going to have, because this opposite side is the same, I'm going to copy it down. Unfortunately, that's the only one we can copy down in this problem. Okay? Because the triangles are the bases. They're congruent with each other, but the rest, most of the time, will not be congruent. All right, here we go. So I'm going to go ahead, and I guess we can say step 4 is to find out the areas of all these separately. So I'm going to start with this one since it's right here. This is a 6 by 3 rectangle. So a 6 by 3 gives us an area of 18. It's only a rectangle, so I don't have to split it in half. It's not a triangle. The next one, let's go ahead and do this rectangle on top here. Okay, this rectangle is a 6 right here. This is 6. But look, it's a 6 by 5. Some of you guys may have wondered what that 5 was doing there for the triangle. Well, it wasn't for the triangle. It was for this top rectangle. This is a 6 by 5 rectangle. The area of that top rectangle is 30 square meters. Now, this is my view where some people have a problem. There is a bottom rectangle up under there. Okay? We can't see the actual rectangle, but here's what we can see. We can see the rectangle's edges, and that's what matters. This rectangle is a 6 by 4. It's a 6 by 4 rectangle, which gives us an area of 24 square meters. And now comes step 5. We're going to add these up. So here we go. 6 and 6 is 12 plus 18 plus 30 plus 24 equals 84. And then, of course, just like before, put your units on. Do not forget, though, it is squared, 84 square meters. Okay, triangular prisms. All right. idea is still the same. It's just a couple of changes, right? 5 sides instead of 6. And be careful, there's only one set of twins there, not 3. Questions? All right, here's the one I want you guys to try. Is try out, just taking a look, 671, number, what was it, 15, number 15. 671, problem number 15. Okay, I can see some of us are done, some of us need more time. Okay, here's what I want you to do, because of time factor, I'm going to give you guys 30 seconds. Share with your neighbor what you do have, and then I'm going to do the rest with you guys. 30 seconds, turn to your neighbor, go. Okay, here we go. Eyes up here. All right, so the first thing I'm going to start off is with the triangle. Now, I usually don't draw the dotted line, like seeing it like it's transparent, like you can see through it. But here's why this is important, because down here, this triangle shows that this is a right triangle. What that matters is that this is the base, that is the height. That's why that matters. So this is 1/2 times 3 times 4. So 3 times 4 is 12. Half of that is 6. Very similar to the one we just did. The base triangle is also 6. Here we go. Rectangles. The front rectangle is a 5 by 7, which gives me the area of 35. This right rectangle over here is that line right there is a 4 by 7. A 4 by 7 rectangle is the area of 28. And this rectangle over here on this left side is a 3 by 7, which gives me an area of 21. I add them up. I have 12 plus 35 plus 28 plus 21 equals 96. It's in feet, so it is 96 square feet. All right, surface area prisms.